Good evening, everybody. We want to draw Lewis dot diagrams. That's the purpose of this video, and this is what a Lewis dot diagram are. An example of one. Now, there are three basic reasons. This is water, and it helps show its shape. It's helping determine its chemistry. It tells you what kind of bonds you're going to have between different atoms, and it's also going to show you where you've got lone pairs if you've done them correctly. There are three basic rules, right? You got to use the symbol from the periodic table. The dash is 2 electron, and these things are called lone pairs, and they're unshared. You're going to need to know your valence electrons and how to draw the number of valence electrons you have for any given element, and how to draw the Lewis dot structures for any given element. Remember, valence electrons just go 1 through 8, and in working order as you go left to right. The exception of that is helium, and helium has 2. And the Lewis dot structures, you can see you just add a dot every time, and they spread out, and then they make pairs like that. And these X's go for any of the elements, all right, in the group. So here are the steps, and I'm going to run it through for water. So this step is about finding the total valence electrons. And so you look, hydrogen's got 1, oxygen's got 6, all right? And I've got 2, so I'm going to multiply 2 times 1 and then add 6, and I'm going to get 8, all right? The next step is you're going to, as it says, and there's a bit of an exception, you're going to look for your central atom. It can never really be hydrogen because hydrogen only can make 1 bond. So in this case, it's going to be oxygen. And then you're going to place the other element around it, the H's, and then you get in single bonds, all right? And that's that step, okay? Now it says subtract bonding electrons from count. I had 8 electrons to dole out, so I've got 2 bonds. Each one means 2, so that's 8 minus 4. That gives me 4 left. And then I add those to anybody that needs more. Hydrogen only needs 2, but oxygen needs 8. All right? So I'm all set. This is the acceptable Lewis structure for water. Now, these next 3 steps I want you to get down, and we will talk about them more and what they mean later. All right, so pause the video for each of these 3 steps. And we'll talk about more what they mean in some other examples. All right, let's run it through for nitrogen. No, sorry, not nitrogen, ammonium. Now, ammonium's an ion, all right? It's a positive charge. First thing, you find how many electrons you have. Nitrogen has 5 valence, hydrogen has 1. So 5 plus 4 times 1 is 9, right? We have this plus charge. So we're going to minus 1 electron and give us 8, all right? Now we need to determine our central atom. In this case, it's going to be nitrogen, and then you're going to place the other elements around it. And you're going to add the single bonds, all right? And then you're going to subtract these bonding electrons from the count. So 8 minus 2, 4, 6, 8 will give me 0. So now I'm done. This is my Lewis structure for ammonium ion. The thing you got to remember with ammonium ion is it's an ion, so ions get bracketed up like this. And there's your charge, all right? Now, this is carbonate ion. So how many electrons? Carbon has 4, oxygen has 6. So 4 plus 3 times 6, so 18 plus 4, all right? Now I've got a negative 2. Now you're going to add the negative 2. So that's 24 total, right? Now what's going to be my central atom here? In the past 2, it wasn't the least electronegative, but this time it is. It's carbon. Carbon's the least, has the lowest electronegativity. Now I'm going to add single bonds, subtract them. So 24 minus 6, because I got 3, that gives me 18 left. and then I'm going to place them in. All right. Now, excuse me. They all need 8. So that gives 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And then am I done? This carbon here is a problem. It only has 6. So this is a problem. So we need to see if anybody can make a double bond, and oxygen can. All right. These 2 electrons from any of them can get thrown in between it to keep it uh, to make carbon have its octet. So I take these, I throw them in, make that double bond, and get rid of them. And now 18 minus 18 is 0, and everybody has fulfilled their octet. So that's my Lewis dot structure. All right, and I'm going to house it up. And I don't know why these goes down so far. They didn't need to, these brackets. House it up in there. Now, one thing, forgot to get rid of the things. This is actually what it would look like. It would form like a triangular planar model where it would spread itself out. All right. Now, this is Xena tetrafluoride, and this is one that's going to have an expanded octet. So we have 8 for xenon, it's in group 18. Fluorine has 7, so 7 times 4 plus 8 is 28 plus 8 is 36. And what's my least electronegative? That's xenon. Then I add the single bonds, all right? I subtract my electrons, so 36 minus 4 single bonds, 36 minus 8 gives me 28. And then I add the electrons. So that's 6, that's 12, that's 20, 18, and here is 24. So I subtract. Now, this is going to give me 4 left over. Now, if everybody has 8 in this scenario, 2, 4, 6, 8, everybody's got 8. If I have extra electrons, in this case I add those extra electrons to the central atom. Now, the central atom has to be period 3 or below, and xenon is period 5, I believe. So it definitely fits. So I would add the electrons in there. This is an expanded octet in that xenon now is 12 valence electrons. It can do this because of its size. It's a big atom and it can do it. All right. So those are how you would draw Lewis dot diagrams.